Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is a revisiting of a past problem that I've kind of already forgotten about, but I have not forgotten about it now. Day 3, Part 1, the 2021 Advent of Code. The problem is called Binary Diagnostic. And I'm only doing Part 1 for this moment. I'll get to Part 2 sometime in the future. I just had a couple minutes. This is my most polarizing video when it comes to commenting and whatnot, when it comes to best practices versus data versus code versus this versus that. It also happens to be my most watched video for whatever reason, maybe just maybe because people have found other better people to watch over the course of the days, or maybe just people are falling off as they usually do as the problems get harder. For whatever case, here is the problem. Here is the revisiting of the problem. So you have a bunch of data. You have a lot of lines of data. Look at all those zeros and ones. And what you basically need to do is go through column for column and figure out, are there more zeros or are there more ones? And you keep whichever one is the greater number, at least for the gamma part of this. There's a gamma and an epsilon, right? So the gamma is basically what happens when I keep the larger number. So according to what I read here, and I'm just going off what I see here, there's more ones in the first column, there's more zeros in the second, more ones in the third, more ones in the fourth, and more zeros in the fifth. So that gets you to this number, which of course in binary is 16 plus 4 plus 2 is 22. And so that is the gamma. And then they say the epsilon is the opposite of that. You just keep track of whatever the smaller number is, or the number that comes up the least. So that would be the opposite of what you see, which is 0, 1, 0, 0, 1, and that comes out to the number 9. And when you multiply those two numbers together, you get the 198, which is what the puzzle is basically trying to ask. So that is it here, right? So there's my answer. I didn't want to give it away so quick, but that's okay. So the answer will be 1,071,734. But let's see how I get to that with the code per se here. Yeah, part 2. Okay. So the code, because everyone was saying, oh, I write terrible code. I do all these things. What's for that? You can say what you want. It was terrible code. It was just hacked together. And now the code looks like this. Holy moly. You could see that nobody in their right mind. I will not remember this 1 hour from now when I come back, let alone tomorrow or next week, especially without comments. Why would I comment anything? That's what job security is for. I'll vaguely remember what I did a year from now, and then I'll fix it up and do what I did. That's all tongue-in-cheek, of course. I'm just kidding. So I haven't really I haven't dove in. I have dove in. I haven't jumped in. I feel like Porky Pig there. Haven't jumped into Numpy very much, but apparently everything looks pretty easy. It's just a matter of just a new API to learn to use Numpy as a faster way of using arrays and whatnot. And so what am I trying to do here? Like I explained what I'm trying to do, and this is the code that absolutely does it and gets you the same answer. Just to prove it here, I could clear this and run this code, and you can see I'm not trying to yank your chain there. Okay, so I open the file, and then this is where a lot of the work comes out. I read everything in, and I read it line for line for line for line. And then what I do is I take a line comes in as a string, and then I strip off the new line character, and then I go ahead and for every element, which is every character in that string, I go ahead and convert that 0 or 1 into an integer, and it's a list of integers. And then it's a list of lists at the end of the day. So it would go from being a list of strings to a list of lists where every element is a character of the string that it's composed of. And then I learned as I did this that basically, if I want to work this out, because I would, as the example was showing in code, or over here on this side, is that I would have to go vertically through it. I'd have to do a vertical slice, and not that I don't know how to do that. I guess I don't know how to do that. But I figured it would be a lot easier, and it would probably be a lot faster if I just transposed the matrix up front, so everything kind of, instead of being 5 by 10, it's 10 by 5, and all 10 elements are in the same list, and that's what transpose does. And so it transposes this 5 by 10 matrix into a 10 by 5 matrix, And then after it does all of that, now it goes again line for line through that, and it keeps track of all the ones and all the zeros and puts it into whatever data structure a bin count returns. So, and then that's a list of them. So let me just show you what comes up when I get to that part of the code here. So all of this results in something like this. And this is for the big data here. So I have a lot of data here, whatever. And there's 1,000 columns or 1,000 rows, and you can see it goes through all 1,000 of the first, like the first element in this thing. It goes across all of them and basically keeps track of the fact that there were 512 zeros and 488 ones. And you do that for all all 12 rows, because there's 12 characters to this thing, to the number that's going to come out of this thing. Because it's 12 by 1,000, which gives me 1,000 by 12. That makes sense, right? As I was saying, it's just a complete transposition of the matrix. So then all I do from here is, now that I have this information, which is more, I go ahead and now I go through this and I say, okay, cool. Now let's take every one of these and let's see if there are more ones than zeros, then go ahead and put a 1 into, basically put a 1 into a string. But this is a, whatchamacallit here, a relational operator. So that means this returns a true false, literally string true false, which the integer converts it to an int of 0 or 1, and then it converts it into a string of 0 or 1. Oh my god, right? So every element, after it goes through, hey, there's more ones, takes the 1, puts it into a string, and then puts a 0, puts that into a string, puts a 1, puts a 1, puts a 0. And so then when I do all of that, and with the join operation, I end up with a binary string, a string of just binary digits, 1 0 1 1 0 0 1 1 0. And I have learned then that the easiest way to take a binary string and convert that into a true integer is just to say, hey, integer, I can take take this string and say, oh, I know that this string is in binary, so just take the binary string and convert it into an integer. And now I have my gamma value, which is, my gamma value in this case is 281. And you're like, well, why didn't you keep track of epsilon at any point of this? And the reason I did not is because, if you remember back to it, it was just a complete opposite of the binary string is the complete opposite of the one that I get when I do the gamma. So all I have to do is subtract off, in this case, like 2 to the 12th power. That's what length of data is. There's 12 elements in this thing, right down here. 2 to the 12th power is, 4,090 something? 4,000, 2,096, right? Or 4,096, something like that. And so basically all I have to do is subtract off 4,095 from that, and I will get the epsilon value, multiply the two numbers together to print out the solution of 1,071,704. This is definitely a mouthful for this is have you ever seen, I don't think I've ever talked about 4 lines of code for this long amount of time, because every line of code just has just so much stuff in it. And like I said, like when I do teaching and those kind of things, and when I like shorter lines of code that are easier to explain, but not everybody likes that. The Python people love it this way, and I don't blame them. It's fun. This was a fun exercise for me to reduce down that horrible code I wrote just to get the job done 10 days ago into something like this. And now I'm going to take this, and of course I'm going to start working on part 2 when I get an opportunity. But there we go. There we have it. And that is my revisiting of this. And if you have a better way to even reduce this down further, I would love to hear it. Or if there's just a different alternative way that is only a couple lines of code, please let me know. And share, and everyone who watches this video will be able to read your comment, and we can share that. So thanks for sticking it out with me. Thanks all of you guys who watch my videos. I appreciate all the watching you do for all the work I do here. I just love December is the fun month. I get to learn some stuff, and not too many people bitch me about it. Have a good day, everybody. See you in another video. See you next time. Take care. Bye bye.